In this video, we'll be looking at solving word problems using our right triangle trigonometry. Let's go ahead and put our 4.8 up here for good labeling. And we're going to be discussing two new kind of definitions, and those are going to be our angle of elevation and our angle of depression. So the angle of elevation is literally like if you were laying on the ground. Say this guy right here, he's laying on the ground, and you're looking at the bottom of a tree. The angle of elevation measures upwards towards the top of an object. So you'd be looking down, and then you lift your eyes up, and that angle that's created is the angle of elevation. Now the angle of depression is a little bit different because we'd have our right triangle where we'd have our ground. And the angle of depression is when I measure, if I'm looking out, so this is the line of sight, if I am looking out, then I would look down to my object. So the object is lower than where I begin viewing, so I'm looking out of the lighthouse and I'm looking down towards the boat. So the angle of depression looks in a downward direction. Now notice how our angle of depression is outside of our triangle. If this is my right triangle with the height of the lighthouse, the distance to the boat, and our hypotenuse, the angle of depression is on the outside of our boat. But this angle right here is equivalent, would be equivalent to our angle of elevation from the water to the top of the lighthouse. So this x right here would be the same value as right here if I were to lift like that. So these two angles are equivalent. So we can say that the angle of depression is equal to our angle of elevation. And that's something we're going to lean on as we work through a couple of these examples. And then as we move further down and we look at this last box kind of illustrates that when I have an angle of depression, so if I was looking out from the White House and it was 35 degrees down to the bottom of the boat, looking down for angle of depression, that is equivalent to my angle of elevation. If I was looking from the bottom of the boat up to the lighthouse, those would be equivalent. And that kind of makes sense. If I'm looking straight out and down towards the bottom of the boat, it's the same as if I'm looking straight out and up towards the top of the lighthouse. Okay. So we're going to flip this page over, and let's see if we can't tackle a few examples. Okay, so we want to find the angle of elevation if I'm standing 400 feet away and the building is 850 feet tall. So they give us a picture with a nice building and 400, but I want us to kind of more look at this without that picture and see if we can't draw our own. So we'll draw a triangle, which is going to be a right triangle, so we can put our right angle in there. And we know that we are 400 feet away from the building, and the building is 850 feet tall. So we're going to say the building is, like a building would be vertical, so we'll call that 850 feet. And then the distance from the building to our feet, we're standing over here, so let's say we're standing right here. The distance along the ground from the building to our feet is 400 feet. And the question is asking, find the angle of elevation. So the angle of elevation will measure from the ground up to a line that is viewing the top of the building. So we're measuring from the ground up, like so. And that will be our x. Now once we have our triangle drawn, we do our labeling, and then we do our thinking, and then we choose our correct trig, and then we solve. So in order to even think about this, let's first write our 9-letter acronym. So I'm going to write it right here. We'll put so, and then our ka, and then our toa. SOHCAHTOA. So we need to use that SOHCAHTOA to help us keep everything straight. So now I'll label everything. I have my theta right here. There's my angle. Looking across from my right angle, I have my hypotenuse. And now across from my angle of focus is my opposite side on the opposite side of the triangle, so that's our opposite. And then our third side will be our adjacent side. Now once we have our triangle labeled, we think about, well, what am I working with? And then which trig should I use? So I'm working with, it looks like I have an angle, I have an opposite number, and an adjacent number. So I'm working with opposite and adjacent. And I'm going to go back to my SOHCAHTOA, which is working with the opposite and adjacent. Well, that's opposite and hypotenuse, so not sine. That's adjacent and hypotenuse, so not cosine. There's opposite and adjacent, so we'll use tangent. So tangent uses opposite and adjacent. So now we can set that up. So I'll say tangent of my angle is equal to my opposite over adjacent. So now it's time to plug in. Well, my angle, my theta, is going to be my x. That's my unknown. That's what we're looking for, the angle of elevation. My opposite side is 850. And my adjacent side is 400. So we have our trigonometric ratio equation set up, and we're trying to solve for x. To get to x is inside of tangent. We put x inside of tangent, so we need to cancel tangent out. The way we cancel tangent is by using our tangent inverse tangent. And then whatever we do to one side, we do to the other. These two will cancel out, and we'll have x equals inverse tangent of 850 over 400. Using our calculator, plugging that into my calculator. Oh, that's a bad lighting on that. Plugging in tangent inverse into my calculator. 850 divided by 400. And we get, rounding to one decimal place, 64.8. We did inverse tangent of 850 over 400. That is 400. It's just out of the picture a little bit, like so. And we get 64.8. And we are measuring the angle, so we'll want to put those units in there. So we'll say x equals 64.8 degrees. Okay, let's move on to number 2, which has an angle of depression. So we can still kind of go through the same process, where the first thing I want to do is draw a triangle, and we know we're going to be working with the right triangle. And we'll include the ground on our right triangle, like so. Okay, so from the top of a tower, the angle of depression to a stake on the ground is 60 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? So we have a tower, and from the top of the tower, there's an angle of depression that is 60 degrees. And we know the top of the tower is 80 feet above the ground. So the top of the tower is 80 feet from the ground. So we can label this side 80 feet. We're looking for how far is the stake from the foot of the tower. So the foot of the tower is at the bottom of the tower. That's the foot of my tower right there. And then the stake would be out here. It's like a stake in the ground, like a tent pole or a stake piece of wood that's stuck into the ground. So if we're looking for how far is the stake from the foot of the tower, that's our x. That's our unknown. So now this angle of depression idea. From the top of the tower, the angle of depression to a stake on the ground is 60 degrees. I really like this picture up here because because it helps us to see that the angle of depression is kind of on the outside of my triangle. So I can draw a dotted line to represent kind of like my line of sight. And then this is the angle of depression, going from that invisible line or imaginary line down to my triangle. And that's going to be my 60 degrees. And like we had just discussed on the other side, when I have an angle measurement for my angle of depression, it's equal to the angle measurement of my angle of elevation. So I can take that 60 and I can put it in this bottom right hand corner right here, like so. And now I have my triangle and I'm ready to solve for x. So we do our identifying. Well, here's my theta. Then I identify my right angle, and across my right angle is my hypotenuse. Using my angle of focus, I go to the opposite side of the triangle, and that will be my opposite. And then the third side, touching my angle of focus, is my adjacent. Now we think about SOHCAHTOA and what I'm working with, and I'm working with opposite and adjacent, and that would be the TOA part. So we're looking at an opposite and adjacent, so we'll use tangent. So we'll say tangent of our angle is equal to our opposite over adjacent. Time to plug in some values. So our angle here is 60 degrees. Our opposite side is 80, and then our adjacent side is x. This is one of the ones where x is in the denominator, so we have to multiply both sides by x to move it out of the denominator. We'll bring down our x times tangent of 60, and that's equal to 80 after the x's cancel. We'll divide both sides by tangent of 60, dividing by tangent of 60. That cancels out on the left-hand side, and we'll have x equals. Using my calculator, I can go 80 divided by tangent of 60, and we'll get 46.2. We have to bring our units in. So is this an angle or is this a side length? Well, x is a side length, and we're measuring everything in feet, so we can say it's going to be 46.2 feet. So now what I'd like you to do, if you wouldn't mind, if you're feeling a little comfortable, if you're feeling comfortable with this, pause right here and try number 3 on your own. So pause the video right here, and then you can try number 3 on your own, and then when you unpause it, I will go ahead and attack it myself. Okay, so hopefully you took a chance to try this on your own, and thank you for coming back to check on your work. So we'll draw our right triangle again. We know we're going to have some right triangles, so we'll draw our right triangle. And this problem says, a ladder leaning against the house makes an angle of 30 degrees with the ground. The foot of the ladder is 7 feet from the foot of the house. How long is the ladder? So here's our house, vertical. Here's our ground, the horizontal. And then the hypotenuse will be our ladder. So the sides, I think, are pretty easy to fill, or easier to fill in. The foot of the ladder is 7 feet from the foot of the house. So foot being like your feet and they're on the ground. So the foot of the ladder is 7 feet from the foot of the house. And then our question is, how long is the ladder? Well, this left-hand side is our house, and the hypotenuse is the ladder. So that's going to be our x. That's what we're curious about. How long is the ladder? Now, let's figure out where this 30 degrees goes. A ladder leaning against the house makes an angle of 30 degrees with the ground. So the ladder is making an angle of 30 degrees with the ground. So the ladder makes an angle of 30 degrees with the ground. So there's our ladder, there's our ground. This is our angle. Now that we have our triangle built, we can start labeling. There's my theta, my angle of focus. Across from my right angle is my hypotenuse. Across from my angle of focus is my opposite. And then our third side that is touching our angle of focus would be the adjacent side. Once we've labeled, we can identify what we're working with and then choose the correct trig using our SOHCAHTOA. So, I'm working with a hypotenuse and adjacent, and I'm going down the line. So, that's opposite and hypotenuse, so it doesn't work. Adjacent and hypotenuse, well, I have an adjacent, and I'm looking for hypotenuse, so we're going to use cosine. So we'll say cosine of our angle is equal to adjacent over hypotenuse. So our angle is 30 degrees, our adjacent is 7, and our hypotenuse is x. Now we can go about solving this for x. X is in the denominator, so we'll multiply both sides by x. We have x times cosine of 30 equals 7. Then we'll divide both sides by the cosine of 30. Cosine of 30 cancels, and we have x equals 7 over the cosine of 30. So x equals, using my calculator, 7 divided by cosine of 30. X equals 8.1. And using our units, since we were measuring this side in feet, well, we must be measuring our hypotenuse in feet. Well, that's it for this video, and so I want to thank you very much for watching and participating, and you guys have a great rest of your day.